Very good afternoon, my dear students. Very good afternoon. Welcome to yet another session from myself on Unacademy YouTube live classes, my dear students. Hope you all are doing fabulously fine here. So now, with reference to today's discussion as such, we will be focusing majorly on thermodynamics, the important problems on thermodynamics, my dear students. Okay, so I hope you all are doing fabulously fine, and I want to see your messages here so that I'll get more energized. Welcome, my dear students. Welcome. In fact, it's a matter of fact that now we started off with YouTube live sessions, and with your love and affection towards your teacher, okay, it made me grow to the fullest extent. Now at another session I'm up with thermodynamics, the important problems on thermodynamics, and thermodynamics happens to be one of the hot favorite hot favorite topic for any entrance exam as such, my dear students. So hence, with reference to these all things, okay, so I'm focusing majorly on thermodynamics problems, and next two sessions I'll be concentrating on thermodynamics itself. Okay, so you all show me that kind of love and affection forever, then I'll be highly obliged, and I will always keep on delivering the best classes on Unacademy. So let's begin our discussion with important problems on thermodynamics. Okay, so let's begin, my dear students, now. So as you know, myself, I'm Uttam Kumar Umarji. I'm an MTech graduate. I'm your personal physics teacher. I'm holding presently 19 plus years of experience, my dear students. And again, with the love and affection given by students, I'm at number 2 position in Karnataka CET segment. And I'm with a lot of proudness. I'm here on YouTube, my dear students, for giving you the best classes on an academy platform. So here it goes with my experience as such. I've taught JEE Advanced and JEE Main Physics for 19 years at Delhi, Kota, Bangalore, and almost all across India, my dear students. And I've taught closely to 10,000 plus students till date. So obviously, I have that kind of student data bank. In fact, there are so many students who are still giving me a lot of love and affection. In fact, currently I'm working at Prarthana PU College, and this is my third month. It's almost 3 months getting completed, my dear students. So it's been one of the highly energizing journey on an academy platform that I came up with this very nice and beautiful experience, my dear students. So in fact, I'm very much fond of an academy platform because of the very reason, my dear students. So here, by the grace of an academy platform, let me just move ahead on this particular session. Okay, and those who have not set the quality aspect, please set the quality aspect to 480p and above. Then your video will look clearly, my dear students. I'm just checking my video quality. So 480p would be ideal, or else you can go with 360p as well. Okay, fine. Now let's progress with our next part of discussion, that is what Unacademy can offer you. Unacademy can offer you a lot many things, and specifically Unacademy can offer you a plus subscription. So plus is always an added advantage, because we keep on saying that I have a plus credential. That means obviously you have an additive bonus. You have an additive benefit given by Unacademy, my dear students. And as you all can see, Unacademy Plus subscription, we have eventually three plans which are laid out for Karnataka CET 2021 aspirants, and KCET 2021 aspirants. We have first golden plan, that is a 12-month plan, which would cost you 12,375 rupees, and you can avail an EMI of 1,031 rupee per month. And then we have a 6-month plan, my dear students, and the 6-month plan, it comes at 10,125 rupee, and with an EMI benefit of 1,688 rupees per month. So this is 6-month plan, and we have a trial plan which would cost you 2,250 rupees, and this is simply a 1-month plan, my dear students, and this is specifically for new subscribers. For new subscribers only, we have this 1-month plan in the hand, my dear students. Okay, then as you all can notice here, we have the benefits given to you as premium content at a very affordable price. Obviously 1,031 rupee, 1,688 rupees per month, compared to lakhs and lakhs of rupee that you might pay for online programs. Obviously these are affordable, right? Then plus apart from this, what you will get, you will get a structured live courses, dedicated live doubt clearing sessions, okay, and quizzes are conducted at regular intervals for self analysis, then batches for complete preparation, my dear students. This is one of the important thing. Then test series, it includes daily practice papers, then full length mocks, okay, everything with analysis would be provided to you. Then a single subscription can give you unlimited access. This is Unacademy Karlo Dunia Muthi Mein. So Unacademy Plus subscription, and presently we have a comprehensive batch which is live for complete syllabus, my dear students. Okay, so you can go ahead and enjoy your teacher's gift. I, being your teacher, if you use my code as UTTAMLIVE or UTTAM2021, any one of these two codes, okay, you can avail a straightforward 10% discount. That is an added advantage, my dear students. So here I am providing you 10% discount with the usage of my referral code, my dear students. Okay, so straight away you can get a 10% discount. So this is Unacademy Plus subscription, my dear students. Okay, now with this note, now let me just progress to our session here. I once again welcome everyone for this particular session. So this is the first question, my dear students, that we have for the day. Okay, the first question is, if R is the universal gas constant, the amount of heat needed to raise the temperature of 2 mole of an ideal monoatomic gas from 273 Kelvin to 373 Kelvin when no work is done. Okay, so here amount of heat required they have asked to raise the temperature of number of moles they have given. They have given final temperature, initial temperature. So we can find temperature difference here, and number of moles they have given, and when there is no work is done. So obviously work done is 0. So under this scenario, I would always go with first law of thermodynamics. According to first law of thermodynamics, we have delta Q is equal to delta U plus delta W, and over here delta W is given to us as 0. So therefore we'll get, if I put delta W as 0, I'll get this as what? Delta Q is equal to delta U, right? Then I know that change in internal energy is F by 2 mu R delta T. Okay, F R mu R delta T. Okay, F by 2 is degree of freedom. F is degree of freedom. Okay, so this is the formula that I'll be utilizing here. So accordingly, now for monoatomic gas, degree of freedom, it is 3. So hence I can write F by 2 as 3 by 2 into 2 into R, because number of moles is 2 here, and R universal gas constant, I am keeping it as it is. Then delta T is 373 Kelvin minus 273 Kelvin. So obviously this works out to be 300 times of R. So 300 times of R is option C here, my dear students. Hope it is clear. Any doubts you have in this particular question? I made use of first law of thermodynamics, then over there I substituted net work done as 0, then delta U I have keyed in as F by 2 into mu into R into delta T, where mu is number of moles, delta T is temperature difference, and accordingly F degree of freedom for monoatomic gas is 3 here, so that I have put in place of F. Okay, so accordingly I can very easily see that this is 100 into 2R, so 2 ones are, so straight away I can write it as 300R, my dear students, is it not? Okay, so simply speaking, cancel out these two, then 3 into 100, 300. Now let's progress to second question. Find the change in internal energy of the system when a system absorbs 2 kilocalorie of heat and at the same time does 500 joule of work. Okay, so they say that system is absorbing 2 kilocalorie of heat and it is doing a work of 500 joule. So hence we should find what? Change in internal energy of this particular system. So this is again based on FLOT, that is first law of thermodynamics. So according to first law of thermodynamics, I know that delta Q is given as 2 kilocalories. So I'll write this as 2 into 10 power 3, which is calorie. It will be multiplied by 4.2 to convert it into joule, my dear students. Okay, so that I'll get delta Q is equal to 8400 joule, right? Then they say that delta W is 500 joule here. So accordingly I can comfortably write from first law of thermodynamics, delta Q is equal to delta U plus delta W, and unknown is delta U here. Therefore I can say that delta Q minus delta W is equal to delta U here. Okay, so this is actually, so I can write this as, this is delta U. I'll just correct the error here. So it is delta W, my dear students. So accordingly, as you can notice, delta Q is 8400 minus 500. So this should give me 7900 joule. That is the amount of change in internal energy, and this happens to be option A here in the question, is it not? Fine. So now let's progress to our next question quickly. The third question says that a system performs work delta W when an amount of heat is delta Q added to the system. The corresponding change in internal energy is delta U, a unique function of initial and final states irrespective of mode of change, okay, is. Okay, so in this question, my dear students, we should remember that the change in internal energy, work done, and heat, these are three parts for any thermodynamic process. Now in this particular case, work done and heat added or heat removed, now these are actually the path functions. These are depending on the nature of the path that is followed. Based on that, the network and heat, they change. Okay, whereas internal energy is a point function, so it is based on the states. Internal energy depends on the states, so therefore internal energy can be termed as what? A state function. Okay, so hence we can say change in internal energy, it is the factor that depends upon initial and final state of the function. So obviously it is state function or point function, we can say. Whereas delta Q and delta W are path dependent. They are path functions. So they depend on path only, my dear students. So hence we can say that D is our answer, that is delta U is that particular required function that they have asked in the question, my dear students. Okay, hope it is clear. Now let me just progress to fourth problem now. A container of volume 1 meter cube is divided into two equal compartments by a partition. Okay, one of these compartments contains an ideal gas at 300 Kelvin. The other compartment is vacuum. The whole system is thermally isolated from its surrounding. Okay, so it is thermally isolated. Okay, the partition is removed now, and gas expands to occupy the whole volume of the container. Now its temperature now will be, very beautiful question, a very simple question, and it is usually asked in entrance exams. Okay, this is that quality we can expect here, my dear students. So as we can notice here, free expansion case we are having. Okay, now in this particular case, when we talk about free expansion, my dear students, delta W and delta U, both of them will be zero. In case of free expansion, work done will be zero, change in internal energy will be zero. Okay, so hence temperature will remain same. Since there is no work, there is no change in internal energy, temperature will remain same, right? So that is why I was saying to you that this is a very beautiful problem, because this has got a lot of theoretical conceptual understanding requirement. So obviously if you remember this particular thing, that is free expansion. In case of free expansion, delta W is zero, that is work done is zero, and change in internal energy is also zero. And if change in internal energy is zero, then temperature must remain same, right? So this is the question that we've answered as fourth question, my dear students. I hope it is clear. Any doubts, my dear students here? Do you have any doubts? Please ask me. If you have any doubts, please ask me. Okay, thank you. Very good, Prasanna. Prasanna has answered. I'm unable to see the chats. I was unable to see the chats. So just now I saw your answer, Prasanna. Very good, Prasanna. That's a good spirit. So here we can go to fifth question now. 110 joule of heat is added to a gaseous system whose internal energy change is 40 joule, then the amount of external work done is. Okay, so heat added they have given internal energy change. Okay, then we should find work. So this is a straightforward FLOT, first law of thermodynamics problem. Yes, okay, so accordingly, So here delta Q is equal to delta U plus delta W. That is the situation that we have. Okay, so accordingly I can say delta W, that is the work done, is equal to what? Delta Q minus delta U, and delta Q is given as 100 and delta U is given as 40 for us. So therefore the answer is 60 joule, right? This is 60. This is a misprint, so I'll just erase this off. This should be 60 joule. Okay, so 60 joule happens to be option B here. Now let's progress to question number 6 here. Yes, the specific heat of hydrogen gas at constant pressure is Cp equal to 3.4 into 10 raised to 3 calories per kg per degree Celsius, and at constant volume it is Cv equal to 2.4 into 10 raised to 3 calorie per kg per degree Celsius. If 1 kilogram of hydrogen gas is heated from 10 degrees Celsius to 20 degrees Celsius at constant pressure, the external work done on the gas to maintain it at constant pressure is. Okay. Now, firstly, we'll say first law of thermodynamics, float. From that we know that it is delta Q is equal to delta U plus delta W, my dear students. So accordingly, work done at constant pressure can be calculated now. It is given by delta W at constant pressure is delta Q at constant pressure minus delta U, right? So accordingly, I can say that delta P minus delta Q at constant volume is equal to, now at constant volume we know that delta Q at constant volume will be equal to delta U. This is the fact I know, because at constant volume work done will be 0, therefore heat is equal to change in internal energy, right? So hence I'll say that delta QP minus delta V, I will write this as, so I'll write this as equal to here. Okay, so hence we also know that delta Q at constant pressure is what? mCp delta T, and delta Q at constant volume is mCv delta T. So accordingly I can substitute these values here. So therefore delta W at constant pressure would be what? M into Cp minus Cv into delta T. Okay, now here Cp minus Cv we can also write it as universal gas constant in that way by taking number of moles, but will not do that since they have given us Cp and Cv, so straight away we'll substitute that. So hence delta W at constant pressure would be mass is 1, right, into Cp is 3.4 into 10 raised to 3 minus 2.4 into 10 raised to 3, this is 1 into 10 raised to 3, and delta T is obviously 20 minus 10, that is 10. So hence we'll get this as 10 power 4 calorie, 10 raised to 4 calorie. So this is obviously option B here, my dear students. So I hope I'm clear on this part. Now let me just talk about 7th question quickly. Now, in a thermodynamic process, pressure of a fixed mass of a gas is changed in such a manner that the gas molecules gives out 20 joule of heat and 10 joule of work is done on the gas. If the initial internal energy of the gas was 40 joule, then the final internal energy will be. Now this question, they, instead of asking you find the change in internal energy, they have given initial internal energy and we should find final internal energy. So prior to that we should find change in internal energy, then we will say change in internal energy is equal to initial minus final. So thus I can find final internal energy, right? So hence we will just progress with the solution here. So from first law of thermodynamics, I'll write delta U plus delta W is equal to delta Q, and delta U is UF minus UI. final internal energy minus initial internal energy plus delta W. So accordingly, I can write this as delta Q is 30. So that's equal to UF minus 40 I will mention plus delta W is 10 here. So hence I will substitute all this. Then minus 40 plus 10 will give me minus 30. So therefore UF will become equal to 60 joule. Is it not? So UF is 60 joule. 60 joule happens to be option C here, my dear students. Okay. I hope I am clear on this part. Any doubts, dear students? Hope no. Okay. Now let me just move on to the last problem for the day. Okay. So 1 mole of an ideal monoatomic gas is heated at a constant pressure of 1 atmosphere from 0 degrees Celsius to 100 degrees Celsius. Okay. This is 1 atmosphere. Then the change in internal energy is, okay. See here, 1 mole of monoatomic gas is heated at constant pressure of 1 atmosphere from 0 degrees Celsius to 100 degrees Celsius. So temperature change they have given, then change in internal energy they have asked us to find. Okay. Now in this particular question, change in internal energy, we can say that it is always equal to heat supplied at constant volume. Is it not? So hence I can say delta U is equal to delta Q at constant volume, and delta Q at constant volume is what? Mu into CV into delta T, where mu is what? Number of moles, my dear students. Okay. So accordingly, I can write for monoatomic gas, CV is 3 by 2 times of R. That fact, I know that, right? So, and therefore, delta U will become equal to what? Mu into 3 by 2 R into delta T. Okay. Now, over here, mu is 1 mole. I am considering number of moles as 1 mole here. Then 3 by 2 into R is 8.31, right? Then 100 minus 0, 100. So this is where I can say that it is 2 ones are 250s I will get, right? So 50 into 8.31 into 3. So that will be the required value for delta U. So I can say that it is 12.48 into 10 raised to 2 joule. Okay. So this is the answer that we should write as. Okay. So 12.48 into 10 raised to 2 joule is the required answer, my dear students. And here with this note, this will be the end of my session because it's almost 3:29 p.m. here. So this half an hour session, I've tried to cover some 8 good quality problems for KCET pattern. Okay, I hope you all enjoyed this particular session. Hope you will look forward for many more such problems on YouTube live platform. Okay, so I hope you all have enjoyed this session fully. So how was the session, my dear students? Was it good? Was it beneficial? Was it fruitful? So with this note, without much ado, then I'll just push ahead. I'll just move on and say bye bye to each and everyone. Thank you for attending this session with full of josh, full of energy. Now, before we sign off, shall we just say let's crack it? Okay, so I will write here as let's crack it. Let's crack it. So, Unacademy, we always keep on saying let's crack it. So we have cracked 8 good number of problems here. So with this note, I'm closing down today's session and have a nice time. See you. Bye bye.